Hello. On this episode of the podcast, we will be discussing a recent experiment titled Open Channel Flow, where the free surface profiles for steady, slowly varying flow were determined and then compared against theoretically determined profiles for the given bed slope and Manning roughness coefficient. Here's a picture of the position along channel X versus depth of water Y for the theoretical and experimental S1 profiles, where the line is the theoretical and the dots are experimental. Notice how the water is getting deeper, but very slightly the slope of it is decreasing. And here is a picture of the theoretical and experimental S2 profiles with depth and X. Notice how the depth is decreasing, but it does seemingly reach an asymptote. I've been giving some questions beforehand regarding this experiment and the results, so I will try to answer those. So the first is, for an established flow, if the upstream gate is at Yn and the downstream gate is removed, will the depth remain constant at a value of Yn for the entire flow? And the answer is yes. If there's nothing blocking the flow downstream, there's nothing that could create a hydraulic jump or anything that would give it a different surface profile. And then calculate the Yn value from the S2 profile asymptote and compare it with the earlier results. My value was 0.021 meters just from the asymptote of the graph, and that would give a roughness coefficient of 0.0042, which is very similar to the calculated value beforehand, as the Yn value was very similar. And then next, what is the flow profile upstream of the hydraulic jump when the S1 profile forms downstream? And the answer to that is it's an S2 profile. The water will get faster and more shallow leading up to the hydraulic jump before the kinetic energy is converted to potential energy, where the flow will be a lot deeper, a lot slower. And then next, how sensitive are the numerical results to the value of Y1? They are fairly sensitive. I'd say the measurement's not incredibly accurate just from the measuring equipment, but I think it could be improved by putting more data points closer to X1 for more measurements, reduce errors. And then how flat is the S1 profile compared to the ground? And that answer, it gets very flat. Looking at the graph, it levels off to basically the slope of the channel, which evens out to being flat with the ground. And then next, how sensitive are the theoretical surface profiles S1 and S2 flows to the changes in the Manning roughness coefficient? And for that question, I can show you that from these graphs, if you change the Manning coefficient by 10%, this will be the S1 profile, which is very similar. And this will be the S2 profile, which is still very similar to what was shown before, showing that these profiles are not too sensitive to a change in N. And finally, an assertion is made that for large X, the surface of an S1 profile becomes horizontal with respect to the laboratory datum. Can you prove or disprove this assertion? Well, the surface slope is decreasing with respect to the lab datum. Eventually, it will even out with enough distance X because it can be going downhill. It can't be going downhill without something that is acting on it, or else that would be S2. And thank you for watching the podcast. I hope this answered your questions and gave you more insight into the experiment, open flow in a channel.